And since this is a reference angle, I'm actually going to go back and call this theta prime, just so that we can differentiate, of course, between theta prime, which is negative 30, and theta, which is really what we want to find here. So let's go ahead and continue with our steps by setting up using, well, what we know, since negative 30 degrees is our reference angle, if this is negative 30, 360 degrees plus that angle, negative 30, well, that's 330. So formally we can say that theta is 330 degrees. So we have R, we have theta, we have N. We're going to go through our K values as we did in the last problem and getting going here with K equals 0 first. So again, using the formula from up above, we'll take the nth root or cube root of R, which is 8, times the cosine of the quantity. Now again, I could use degrees. I could, though, use radians as well, which is what I will do in this instance again. I'm going to go ahead and identify using my unit circle. As we all remember, 11 pi over 6 is the radian value that equates to 330 degrees. So the cosine of 11 pi over 6 plus 2 pi times 0 all over 3 plus I times the sine of the same thing. When I say same thing, why don't we actually just do this math? 11 pi over 6 plus 2 pi times 0, which is just 0. So 11 pi over 6 divided by 3, well, that's the same as times its reciprocal, so times 1/3, which in turn is just 11 pi over 18. Okay. Now 11 pi over 18, unfortunately, is not on the unit circle. So we are absolutely going to have to use our calculators on this. So let's go ahead and do that. So we'll go ahead and convert to radians. Do our calculation here with the cosine of 11 pi over 18. And that is negative 0.342. Let's go ahead and also write that the cube root of 8 is 2. And negative 0.342 plus I times the sine of that radian value. Well, what's the sine of that angle? Let's just type in second, enter, and then retype over the cosine, making it a sine. So the sine of 11 pi over 18, 0.939. Okay. If I were to distribute the two in both instances, I can go back. Just typing times 2. Negative 0.684. And then in the other instance, I'll just hit second enter, times 2, 1.879. Positive 1.879. Don't forget your I. This is one of the 3 roots. We'll work our way up to k equals 1 now. Doing the same basic thing with the cube root of 8 times the cosine of 11 pi over 6 plus 2 pi times 1 now all over 3 plus I times the sine of the same thing. Well, let's again find that angle. We'll go ahead and take 11 pi over 6 plus 2 pi. Let's think about what 2 pi is in terms of sixths. In other words, multiplying 2 pi by 6 over 6, that's 12 pi over 6. 11 pi over 6 plus 12 pi over 6 should end up being 23 pi over 6. (23 pi over 6 over 3 is 23 pi over 18. And again, 23 pi over 18 is unfortunately not on the unit circle, so we are going to have to use our graphing calculator again. So 2 times, doing the same process. We end up with negative 0.642. Negative 0.643 we'll round to. Plus I times second enter, tap up, sine of that angle, negative 0.766. Okay, we'll multiply this by 2. Let's just hit times 2 here. Make our lives easier. So negative 1.532. Don't forget I. And then we'll go back to multiplying, hitting second enter once, second enter twice, and a third time, times 2, negative 1.286. That is your second third root. These are both in a plus bi form. Not the nicest numbers in the world, but this obviously can happen. So we'll finalize our solution here with k equals 2 by taking the cube root of 8 times the quantity cosine of 11 pi over 6 all over 2 plus 2 pi times 2, that's all over 3, plus I times the sine of the same thing. What is that? Well, 11 pi over 6 plus 4 pi. Well, what is that? What is that in sixths? 4 pi times 6 sixths is 24 pi over 6. So you got 24 plus 11, which of course is 35. So 35 pi over 6 over 18. 35 pi over 6 over 3, excuse me, over now, as we see the whole quantity, 35 pi over 18. Okay, so let's simplify it, completely wrapping this up. And we'll go ahead and type in cosine 35 pi over 18. I'm going to multiply it by 2 now. Okay, so I get 1.969, or 1.970, we'll say. Plus, or maybe it's minus, let's get ourselves ready for the possibility of this being a negative. Second enter, second enter. Okay. I want the sine of 35 pi over 18. Too many entries to go through. I apologize. Let's just do this. Negative 0.347. So minus 0.347i. Ladies and gentlemen, you have your 3 third roots of this complex number. None of which are complex conjugates of one another. And that may or may not be anticipated or should have been anticipated based upon the original problem. We saw it in the last problem. We did not see it here. Let's finish up. Example 8. Find all the solutions of the equation and represent the solutions graphically. The equation x cubed plus 64i equals 0. Okay, so similar logic will apply here in getting the x by itself, which is what I want you to all consider here. Getting x by itself, x cubed equals negative 64i. If I simply subtract 64i, making it a negative. So if I were to take the cube root of both sides, again using similar logic in what we saw previously, it makes perfect sense here that we're finding 3 third roots. And what are we finding 3 third roots of? We're finding 3 third roots of negative 64i. Let's also, before I obviously solve for x here, which I'm not going to do algebraically, I'm going to do obviously this math with this new formula here. I'm going to write this as an ordered pair, 0, negative 64 as a and b there respectively. R, well, as an ordered pair, 0, negative 64 puts us down here. Oops. Puts us down here. So we can easily distinguish, I would hope, that the R value is 64. Could we still use the square root of a squared plus b squared? Of course, but looking at it does make perfect sense as well. So R is 64. And speaking of things that make perfect sense, looking at the graph, theta is easily identifiable. Theta is 3 pi over 2. Okay. And then n, well, we want 3 third roots. That's easy enough. N is 3. Okay, so let's begin again with k equals 0. We find the cube root of 64 to start with. Multiply that times the cosine of 3 pi over 2 plus 2 pi times 0 all over 3 plus I times the sine of the same thing. And in this instance, we've got 3 pi over 2 plus 0, or just 3 pi over 2. Divide that by 3. 3 pi over 2 over 3, or times a third. Well, the 3's cancel, so this is just pi over 2, as is this. And we can then do the rest here pretty simply without a calculator, I would think. In other words, the cube root of 64 is 4. Cosine of pi over 2, that is 0. And the sine of pi over 2, that is 1. Distribute the 4, we get 0, and then, well, plus or positive 4i. So that's our first root. Let's do k equals 1, so the cube root of 64 times the quantity cosine of 3 pi over 2 plus 2 pi times 1 all over 3 plus I times the sine of the same thing. So let's calculate that. 3 pi over 2 plus 2 pi, which is the same as 4 pi over 2. So we have 4 pi over 2 plus 3 pi over 2, or 7 pi over 2 over 3, which is just 7 pi over 6. Okay. Now, if we simplify this, we get the cube root of 64 to be 4, cosine of 7 pi over 6, negative radical 3 over 2, plus I, sine of 7 pi over 6, negative 1/2. Distribute, and we end up with negative 2 root 3 minus 2i. There is your second third root. And last but not least,